Hi. In the last video we talked about graphing systems of inequalities. And today we're going to continue that discussion, but we're going to talk about word problems and how systems of linear inequalities can help us in real life. So let's talk about a few steps that we're going to take to solve word problems using inequalities. The first one is that we're going to identify what we need to know from our problem. So identify what we need to know. We're going to read over a problem, underline or circle or highlight any important information, and keep that in mind. Our second step is to define our variables. So define variables, and we will have two of them. Third step is to write a system of linear inequalities. So write a system of linear inequalities so that we can actually graph it and solve it. And our fourth step is to graph each inequality. And by this time, when we graph each inequality, we'll see that space where both inequalities overlap, the shading for both of them, and that will be our solution space for our problem. All right, let's try some examples using these steps. All right, so our first example is about a fundraiser. And as I read through this problem, I'm going to underline some things that I find important. So Garrison is helping Skyline with a fundraiser. He wants to raise more than $240, that sounds important. He is selling fruit baskets for $15 each, should probably underline that. And he's selling bouquets of flowers for $8 each, so I'll underline that too. He expects to sell fewer than 20 items, so fewer than 20 items. All right, our first step is to determine what we need to know. So what do we need to know? Well, he needs to raise more than $240, but he also expects to sell fewer items than 20. So we kind of need to figure out how many of each item he's going to sell. So to do that, let's see, we need to know the number of fruit baskets, so number of fruit I'll say, and he needs to know the number of bouquets of flowers. All right, so now we can move on to creating our variables. And we can pull our variables directly from what we need to know. So the number of fruit baskets is going to be, let's call it, I don't know, R. And the number of bouquets we'll call S. So we can use our variables now to create a system of linear inequalities. So we have two different things we're dealing with here. We have money, and we also have the number of items. So we're going to have one inequality for each of those. So let's start with the first one. I'll do it in red. Our first one is about money. So he wants to make more than $240. So he's selling, let's see, fruit baskets are $15 each. So I'm going to say $15 per fruit basket plus $8 per bouquet of flowers. So 8 times S. And this has to be more than $240. So I'm saying greater than $240. Now for my second inequality, which I'm going to do in blue, I want all of my items added up, so all of my fruit baskets and all of my bouquets of flowers, to be fewer than 20 items. So R plus S is going to be fewer than or less than 20 items. All right, so now that I have my linear inequalities, I can graph them. So remember, there are a few different ways that we can use to graph. And before we get into that, let's label our axes. I'm going to label this one R, and I'm going to label this one S. So our first linear inequality, I'm going to use the method where I solve for the R and S intercepts by setting the opposite one equal to 0. And when I do that, for time's sake, I'm going to find that my R intercept is 16. Notice that I have numbered my axes by 5s here. And my S-intercept is going to be 30. So I'm going to find that over here. And now that I have my 2 points, I can connect them in a line. But that line I'm going to have to do something to, because remember, I don't have greater than or equal to, I just have greater than. So my boundary is going to be dotted. Dot my line. All right. And I can graph my second inequality. And maybe I'll take the route this time where I convert this into slope-intercept form. So let's say we're going to use R as my sort of y here. So I'll subtract S from both sides, and I'll find that r is less than negative s plus 20, making my r-intercept 20, so I can find that on my graph, and my slope negative 1. So I'll move down 1 over 1, down 1 over 1, and I will find that my graph looks something like this, and that I will end up over here. So I will have that line, but just like before, I only have less than, I don't have less than or equal to. So I'm going to have to dot my line. And now comes the fun part. So now comes the shading. So let's look back at this first one. Maybe I'll use plugging in points to figure out where I'm going to shade this. So maybe I'll plug in 0, 0 down here. If I plug in 0, 0, does this make my inequality true? Well, if I plug in 0 here, I get 0. If I plug in 0 here, I get 0. So the left side is 0, and this is saying 0 is greater than 240. But we know that's not true. So 0, 0 is not included, meaning I need to shade everything above this red line over here. So my above the red is shaded, and when I shade my blue, I can notice that my r has to be less than this boundary. So everything below this blue line, this blue boundary on my r-axis, needs to be shaded. So everything in there. Now, when I look at my solution set, it's rather small. It's this little area right here that's both shaded blue and red. So right here. Now, what does this actually mean? Well, this means that the number of bouquets of flowers that fall in this little window, so up to about, let's see, probably about 7 or 8, and all of the baskets of fruit that are right in between these two, so about 16 and 20, those are the solution sets for my inequalities. So that's how many fruit baskets and bouquets of flowers Garrison can sell so that he earns more than $240 to the fundraiser, but also sells fewer than 20 items overall. All right, let's move on to the second example. All right, our second example. So Jayla's throwing a party and she wants to figure out how much food to buy. She knows that wings cost $7 per package, so I'm going to underline that. She also knows that hot dogs cost $5 per package, probably important. She must spend no more than $35, so no more than $35, and she wants to buy at least 5 packs of hot dogs, so at least 5 packages of hot dogs. All right, so what do we need to know here? Our first step, identifying what we need to know. We need to know how many packs of each she's going to buy for this party. So we need to know the number of packages of wings, I'll say the number of wings, and the number of packages of hot dogs. And as usual, as before, we can use these to define our variables. So our variables are going to be W for the number of wings, and we'll say H for the number of hot dogs. All right, so now we can create our system of linear inequalities. Our first inequality here is going to be about money. So we have money here, and we also have the number of packages. So our first inequality is about money. We know wings cost $7 per package, plus $5 per package of hot dogs is going to be, let's see, she wants to spend no more than $35. That means that she could spend exactly $35, but no more. So that means she's got to spend less than or equal to $35. All right, our second inequality here is about the number of packages. But it's not just packages of both. It says she wants to buy at least 5 packages of hot dogs. So this has nothing to do with wings. So we're just going to be using our variable for hot dogs. So the number of packages of hot dogs has to be at least 5 packages. So she wants it to be greater than or equal to 5. All right, now we can graph these inequalities. So our first one is in standard form. You can use either way where you identify the W and H intercepts and graph those, or you can convert to slope-intercept form as long as you label your graph with, let's say, W for wings and H for hot dogs on your axes. So I found the W and H intercepts, but it doesn't matter which way you do it, you're going to get the same graph. So if I find those intercepts, I'm going to find that my W intercept is right here at 5, and my H intercept is over here at 7. So I also noticed that I have that equal sign there, so my boundary line is going to be solid. So I can connect these two, and I can graph my second inequality here. H is greater than or equal to 5. So H is this axis, remember. So if H is greater than or equal to 5, I'm going to have to put some kind of a boundary right here at 5. And it's also going to be a solid boundary because I have that equal sign. So I'm going to draw a line straight up through 5 and down. And now I can figure out where I'm going to shade these lines, shade these inequalities. So this first one, I can plug in points, or I can convert to slope-intercept form and figure out where my W will be greater than or less than. So if I maybe pick a point, I can pick 0, 0. It's always a nice one. So if I plug in 0, I'm going to find that this entire left side is 0. Is 0 less than or equal to 35? Yeah. So I can shade everything on this side of my boundary. Now for my other inequality here, H has to be greater than or equal to 5. So H is anything along this line. And if my boundary is right here, this means that H has to be greater than that boundary. So anything is fair game over here. This means that my overlap happens right in here. This is my solution set. So what does this mean? Well, this means that Jayla can buy 5, 6, or 7 packages of hot dogs, and she can buy the corresponding number on my wings axis of wings, but only in this small area. This will guarantee that she spends less than or equal to $35, while also buying at least 5 packages of hot dogs. All right, thanks for watching, and now you can try these at the bottom of your guided notes.